People in Dallas don't want you to say that. The most famous thing of Dallas is where it's JFK was killed.
Belo Horizonte,
And what is it known for?
cheese. It is known for.
Tiananmen Square.
I thought Olympic.
Okay, so, Hina, you want to explain what we're about to witness?
Oh, our
Speak up.
chef, Mr. Dante, is going to show us live how to cook and let us hear the sound, because the famous chefs, they usually cook the best food by listening to the sound of cooking. Wow.
Can you hear anything? So,
Besides for you, no.
sorry,
As soon as Dante unmutes his mic, we'll be able to hear him.
unmute your mic.
Well, no, he's able to hear you. It's just going to echo.
But the problem is we need the sound from here is what he wants, I think.
So the idea is he's going to cook three different vegetables. And what you have to do is close your eyes and just listen and see if you can tell which vegetable he's cooking.
For the experiments, they're going to have it recorded. So what I'm thinking is that to avoid an echo, we'll mute on that computer and he'll unmute on his phone. So there won't be that echo.
That's a good idea, Xavier. That's a good idea.
What you looking for? Plate?
Yeah.
We got some plates right
No,
here.
but seriously, Dante is a ATEX MFA or PhD student, I forget.
Yeah, before.
MFA student,
Yeah.
but he's also a professional chef. And he came up with this idea. Well, he's taken a lot of cooking lessons and he does a lot of cooking. And he came up with an idea for this semester
I think.
that he spends a lot of time listening as he's cooking, and he knows when something's cooked just by listening to it. So sometimes he's on the other side of the room and he says, oh dear, it's cooked, I better go turn it off. And so he got very interested in, and we did a little bit of research online, and other people have had this idea that just by listening to food cooking, you know what kind of food it is and whether it's ready to be eaten or not. Am I close to target, Dante?
Yeah. I mean, just in general, sounds are very important for every aspect of cooking. And I think a lot of the time people are focusing on all the other senses, right? About like looking at the food, tasting it, obviously, smelling the food. So the sound of the food itself is not really super thought of. However, it's like pretty important. A big trend on like TikTok is when they make all of the fried foods dragging the knife over the breading to show that it's crispy. That sound, but I don't think people are thinking about the sound. They're thinking of what the sound represents, which is that it's crispy and yummy fried chicken or whatever. So yeah, I figured this would be interesting.
Okay, so you filming?
Yeah, I'm gonna film it.
So can anybody online hear anything?
Not yet. We're gonna probably mute Evan's thing, and then we're gonna let Dante.
Yeah, because the problem is if I turn my microphone on, it starts looping. Or not looping, but
Did it have to go something?
I think so, yeah.
You made a mute on that computer then?
Okay, so whilst we're wasting everybody's time, do you know how to use Fred the Heretic, Ryan?
No, I do not.
Can you Google Arts Lab Fred the Heretic and share your screen?
Sure.
You should find a page, share your screen.
Dante presents you a clean sound. just finished playing.
Any luck? Okay, keep going down. Oh, no, that's the, go back up, go back, okay, go to OC4ES and research, I think.
Yeah. We
Keep going down.
Provider.
Okay, just search on the website for Fred the Heretic.
Real hungry stew. That's all.
Ryan, do you want to try a link? I just pinned you. Instead of searching around.
Okay, so where is the page with Fred the Heretic software?
No card or.
But this take you to ChatGPT for the header.
But I mean.
Okay, fine. Now go to the message. So say, Fred the Heretic, will you please write a poem about how to tell what food is being cooked just by listening to it?
You can just copy this to screen.
Well, yes. Okay, done. Okay.
He's writing it right there.
Will you write a poem about the food?
This one girl.
How about listening to food cooking to figure out what it is? About listening to the food you are cooking.
Yeah, it's like this sounds.
Write a poem about the food. Food listening. That's interesting. About listening to the food. A poem about listening to the food. Listening. About listening. About listening to the food you are cooking to figure out what it is and whether it's ready to eat. Okay, after the first word poem, add about. Oh, that's too late. Anyway, hold on a second. Okay, please recite the poem aloud.
Who, me?
Yes.
Oh God. Okay. Listening to the pan. A hush, then a whisper. A breath of warm air. The oil awakens, begins to declare. It murmurs in syllables, subtle and sweet, a prelude to something that sizzles beneath. Then hiss, like the wind through the reeds of a lake, a shuddering song only patience can make, a crisp and curling and bubbling sigh, a crackling echo that answers the sky. Is it an onion that weep in the heat's golden hode? Garlic releasing its secret untold? A chorus of mushrooms and whispering arise, lifting their voices like steam to the skies. The surface now singing, the edges turn brown. The scent tells a story, no need to look down. The snap of a crust when the spatula lifts, a symphony build upon audible gifts. A pop and a spark, too hasty to turn. Patience, dear cook, let the embers still burn. A hush, then a whisper, the sound growing thin. The song fades to silence, the meal must begin. The meal must begin. There you go.
So would we give it an A+ for poetry in a poetry class?
That's quite good.
Yeah, it's quite good. No,
It was quite good. It was quite good.
I encourage everybody in the seminar to practice using Fred the Heretic.
Okay, so the first vegetable is going in.
Fred the Heretic to describe as a poet, which can maybe apply for the poem. It's the word for fighting soul of it doesn't kind of go. A poet that this is mine, a word Consider it. With the time. Not quite.
Hey, Dante.
Yeah.
Are you ready?
I mean, it's going already.
Wait, I think your camera's off.
Yeah, I turned the camera off intentionally. Should I put the camera on? Or so the idea was sound. Yeah.
You can't hear that. They can touch.
I can hear them from here, I guess.
But can they hear what anything? They did it. Yeah.
You hear the vegetable boiling. They're both muted. Oh,
Yes, yes, I can.
you can hear it.
Yeah.
What do you hear? What vegetable do you think it is?
Like currently,
Yeah.
it kind of sounds like cucumber almost.
Wow. You're very close. Why does
So
it
okay,
sound like cucumber?
so I mean, it kind of sounded like or sounds like a thin slice, almost like something of like the vegetable like greenish area. I mean, it sounds like it's thinly sliced almost.
I reveal it. Okay.
Dante, I'm just saying I did some stuff with food sometimes. But what is it? Is it like yeah, show us.
I will not disclose until the end. We have to do number 2 first. Or should we?
Okay.
The picture, did he forget to turn the camera off?
No,
Oh,
he didn't. No, the camera's still off.
Well, I didn't really get the sound, but I saw the vegetables when the camera was on, so it would have been easier to guess, but I still didn't get the sound.
It's still 1 out of 3 as well, to be fair.
Yeah.
We have 3 different kinds of vegetables.
Mm-hmm.
What can you hear now?
Can you get it closer, Dante? Can you get any
Yes.
closer?
I
I can't
can't
hear
you
anything
can
right now.
hear-
I
You
can't
can't
hear
hear
anything right
anything
now.
at all.
Your noise suppression off. I don't know if that's a thing for like.
I don't know if that might just be automatic for phones. But if they heard the last one, then
I can hear the last one just fine.
but this one, nothing.
Yeah, I don't think I can hear anything right now.
Maybe they're just silent.
Is it making a noise? Do we know? Is it making a noise?
It doesn't really sound like it.
It's just the boiler making noise. But
Okay, then what? It's probably something that usually doesn't get
Okay,
It's not-
change it again.
So what? Is it like so vegetables?
We're
So
not gonna
it's
tell, we're not gonna tell you, we're gonna put the 3rd vegetable in.
okay. Well, things that usually don't make noise is usually celery or carrots. Those are the ones that don't make very much noise.
he's good at this.
Might just be an experiment on Ryan's abilities for deduction. The
What does that
Alright,
mean? Deduction.
third one is in now.
I can hear hardly anything as well for this one. Can you describe like what kind of noise it's making?
I don't really hear anything either.
Yeah, this one's not making. Well, there's a hiss of the induction, but
Okay, so like what? Like squash? No, that's stupid.
Okay, show him a picture.
of the third one or of the first?
Well, this one.
This is peppers. Oops, that's my face. This is peppers cooking.
Oh, peppers. Very cool.
So
Very cool.
now
Bell
the
peppers.
first
Okay.
one, the first
What was the
one
first one?
was zucchini.
Oh
They're
yeah,
very
zucchini. I mean, they're basically the same exact thing. They make very similar noises whenever they.
And the second one was carrots.
Oh, was it really? Yeah, I could. Yeah, I could. I use carrots a lot.
Okay.
Okay,
Oh,
I think
Dude, y'all seem like really surprised whenever I started naming them off. Dude, Melina can't believe it right now. I don't think really any like.
All right.
okay, it's not that important.
It was around here, right?
Make it nice,
Yeah.
fun play. Little name on it, publish it on the website. Am I good to
Holy-
go?
Yeah,
Okay.
holy crap, Evan, dude, you need to use that because I was seeing their facial reactions and I was like, why are they making those reactions? And it makes sense now. Okay, that's kind of cool.
No, and it's so, at some level, Dante's idea is a stupid idea, but it makes
Hey,
sense.
I got two of them. It kind of worked.
No, but I think we underestimate how we use all our senses to make sense of things. And we tend to overemphasize vision. One of the people in the room is Eric Fulbright, and he uses smell to make artworks. And right behind Yola, what's your name? Flavia. There are some smell bottles. So
A hollow apparatus, it will be utilized soon.
sorry.
So it's currently a hollow apparatus, but it will
Yeah.
brought back to life.
Okay, Tina is going to get you organized, Robert.
Hey, Dr. Stern, can you hear us? Do you want to do a testing to show your screen, to share a screen?
Well, sure, let me do that. Hang on, let me open the PowerPoint.
And are we recording this? Yes.
Oh, he's already set up the recording. Nice job, Dante.
Hey, Dante, that was cool.
Right, just the beginning.
Okay,
Yeah.
we can hear it, we can see it. Great, you can present that way. And you can make it a full screen if you like. So they
Oh, I
can
will.
see.
I'll make it full screen when it's my time.
Okay.
What's your time?
Oh,
When
he's in an hour. We just started. We're doing testing. Make sure he's okay. And you're free. You can, you're welcome to join us to hear our presentation. And you can join back at 8 if you want to.
No, you can just.
I'll just leave you on in the background.
Okay,
Okay.
great. Thank you. All right, and we have agenda today. In the very beginning is class presentation. A great job, Dante, for showing us the sound of cooking, and a great job online, folks. You did a great guess. Very
Face
intelligent.
test.
I'm hoping to do it with better quality equipment at my house so that I can,
Oh,
because I think the phone was also probably not the optimal recording.
we'll try again.
Listen, I didn't guess. I knew what he was cooking up. At least two of them.
Excellent.
I guess
Belinda,
because
Oh.
we saw the vegetables before it was being cooked, you could actually guess, but assuming we didn't see it at all, probably it was going to be difficult because the sound was pretty low and we couldn't actually hear properly. Probably a better equipment could help.
And
I
out
was
of,
messing with Fred the heretic. I didn't see anything.
but even three that were there, it was still a guess, like a 33% chance for the correct one.
Hmm.
No. Next week
Yeah.
we'll do better.
Any other comments to Dante?
Dante, are you currently eating the vegetables?
No, I had my dinner.
Oh, okay, that makes
No,
more
but
sense.
okay, and Robert can add to this. So one of the things I learned in my NASA days was called process documentation. Because a lot of people only write up what they did at the end of a project. Well, in NASA, often the rocket explodes, and to figure out, you need to know what you did 3 months before. And often people don't document it. So I recommend that you write up what you did this evening. Just describe what happened and what worked and what didn't. And then next time you do it, you can document it. So process documentation it goes a little bit beyond just a laboratory notebook. Because it's also your thinking process as you do things. And in my NASA days, a lot of projects fail because people don't write down their thinking aloud. Oh, what if I tried this? Maybe I should have tried that. And so it's so easy now to just type up a process document. So please write what you did this evening, describe it. And I don't care about spelling and punctuation or grammar. But then at the end of the semester, you'll have 30 of these cooking experiments, sonic cooking experiments. And then you'll get the Nobel Prize. Okay, Tina.
Right, today's agenda after Dante's performance, we are going to do a class presentation talking about our publication plans. And whoever is ready, I think Flavia is more than ready. And we're going to have Dr. Stern joining us back at 8 o'clock talking about emergence of Earth systems. And we have a break, and later on, when we come back, we're going to talk about Earth's electronic open calls. That's our opportunity. I'll give the floor to Flavia. Really? This one. Yours? Yeah. We need to close it after presentation.
Hey, how I can share? Share? Are you seeing the project?
No.
No.
Share the screen, I think. Oh,
No, yeah, it's not there. I don't know why.
yeah, that's
Supposed to be that one, but
can folks online see the shared documents? A PDF and or Word?
yes,
Yeah, we can.
Yeah, they can see it. So
We can't see it.
yeah.
So
I haven't tried to.
Turn off the transcript.
You just drag it to the screen.
yeah, you can drag it over. Maybe.
Yeah, I'm trying, but
Okay.
Ah, success.
yes. Okay, so this is my second version to be honest, and so the idea is to understand how artificial intelligence has sparked intense debate about the influence of art and the human creativity. So my purpose is create an experimental podcast that will talk about those possibilities, about art, artificial intelligence, and discuss some impacts. I think that is going to be useful for my research, for my project, and yes. So the objective is to investigate how AI is transforming the creative process in different forms of art, addressing topics such as authorship, ethics, human-machine collaboration, and the evolution of artistic languages in the digital context. So there's a methodology here. It's like I think if I just explain the episodes, you're gonna understand. But I have 5.
Just slow down. I don't have time to read it.
Oh, okay. I'm sorry.
Okay, and I just go
The
slowly.
methodology, right?
Yeah,
So I change the time, the episodes for 10 to 15 minutes. It's bi-weekly, so each 15 days. You test different formats such as interview, roundtable discussions. Yes, I will try to explore some formats. I planning to have some guests and AI specialists. I don't know exactly when I will distribute this, but I have some ideas here. So each episode can be structured or not, depending on the theme. Basically, they have an introduction, a discussion with experts, a practical experiment probably, because I'm always trying those things, and a final reflection. The initial episode that I think is one about the thing called the age of artificial intelligence. How can we look for ourselves in this moment and like historically thinking and how we can think about technology and how the artificial intelligence could influence or not the contemporary aesthetics. So about the relationship between artists and algorithms and how those algorithms will, the possibilities that algorithms shows to us in artificial intelligence. One specific about ethics and authorship, although I think that I will talk about this subject in all episodes and try to answer the question, can AI be creative or is just a agglomerate of information put in a fancy way? And I think about the one about sound and code, because people in this course are really interested about sound, you know, so I think it's gonna be interesting to do an episode about this. And then I wrote a script for the first episode, and I think that it's gonna be good if you just read it, but here at the end, I put some questions about the first episode.
yeah, hold on. Okay, who's John Doe?
I don't know yet.
Oh.
Sorry, I just put
Okay,
the
does
random name.
anybody have a suggestion of someone? she
Yeah,
should
they
have
need a
as guest?
list of guests.
Does anybody suggest a guest that she could talk to? Are
Okay, you
there any
have
faculty in our school that are relevant?
We have some people at school that do AI stuff, right?
Who?
I don't know.
I think Professor Wander Scott, because he's an artist and he also involved with artificial intelligence.
Okay, Andrew Scott would be good. I have a suggestion, but I'll do it at the end when you can pull up the screen.
I think to talk with Professor,
Do you have a list written down already?
yes,
Okay.
I
Okay,
have a
just
new
keep going. I'm
version. Okay, but I need help with this.
Yeah,
I definitely need help.
That's what I'm paid to do.
So I have some questions here, but I just think that it's better if I spend my time with this experiment that I did in Jellypod that Tina kindly encouraged me to try it. And there's an episode there.
Can you show us?
Yes. I think that's going to be more interesting than, oh, you can just copy it. I don't know.
Okay, can the people online help us make sure you can see it? So this is your website with the first exercise?
No, this is an artificial intelligence page.
But it's your page.
Yes, it's my page, and I just create one episode to understand how this works. So I basically put the content there. I copy and paste the content. I recorded my voice to calibrate the machine, and the machine just made the episode for me. I didn't record myself doing this.
Creating has always been central
Turn it
to
up.
what makes us human. From
Dante,
the
can you
first
help me to?
paintings to digital art, every era has wrestled with the concept of what it truly means to make something new, something meaningful. But now we
People online hear it.
think of a fascinating and honestly kind of
Ryan,
I can hear it. I can hear it.
shift. One where machines are not just tools, but in a sense, creators themselves. I mean, take a moment to think about it. When we talk about artificial intelligence creating art, are we standing in awe of a new kind of ingenuity, or are we starting to blur the lines between human and machine creativity? Like, is this stuff even comparable to how we've defined art for centuries? And I don't just mean aesthetically, I mean philosophically, culturally. Maybe the real question is, does it change the role of the artist? Does it, redefine the idea of inspiration itself? And if we uncover what it means to create in this AI-driven world, can we begin to understand whether this is like an evolution of art or maybe some entirely new category? When you think about it, every groundbreaking technology has reshaped how.
Okay, so JellyPod is podcast software available online. Is this, with people on the planet can now listen to it?
Yes. But I also can share in Spotify, YouTube, or wherever.
Okay, very good. Okay, so you have anything else you want to present?
No, I think that is it.
Okay, so Belinda, you still online?
Yes, Professor, I'm here.
Okay, so you have an interest in women in STEM. How
Mhm.
would you connect your interest to Flavia's interest?
Well, I think when she started, I'm like, okay, it's more like we're doing the same thing. And though I didn't think through as women in STEM because I was much concerned with the AI aspect of it, I'm like, okay, probably I can collaborate with her on some of her episodes and then we could talk more about it. But yes, I think it's basically mine. It's amazing. I didn't really think through as women in STEM, but I think I like the idea of the AI and we can do a good job together.
You, Belinda, Flavia.
Okay.
Okay. Dante, you want to connect your interests?
I'm not really sure how the cooking sounds.
Ryan,
No, not right now.
can you publish these podcasts on the website you're building?
Yeah. Oh, yeah, for sure.
Okay, so please contact Flavia and publish the podcasts on your website.
Okay.
Okay, Eric, how could you connect your passion with Flavia's proposal here?
Well, I think it's essential that as it develops, we focus on our role in, our own artistic realms as AI develops. I think I've been very, skeptical of its benefits to art. But I think that with my interest being utilizing olfactory, tactile, which is touch and smell, communication into art.
Do you know any AI software that generates smells?
That's what I'm getting at. Yeah, it might be useful to look to that
Okay,
for some
can you
ideas.
pull up Fred the Heretic and Ask it if we know of any AI software that knows how to. Okay, share the screen. And that was the cooking sounds. You need a new one. Go back to Fred the Heretic. You and Fred the Heretic? Yeah. Okay, so how do you phrase the question, Eric?
Let's see.
How could AI software?
How can AI software help us develop olfactory art?
Okay, can you write that in?
Oh, wait,
It's
and
Ryan.
Old factor.
olfactory art.
No, you have to correct the
Ryan
typo.
is typing.
Olfactory art and nonverbal communication.
No, it says olfactory, not olfactory. It's got the.
Yeah, olfactory is OL factory.
I'm not typing, okay? It's-
Say to write.
They are stupid.
And
No, I just can't spell. Oh my god. I had to... Up. There you go.
Olfactory, what?
Is that correct?
No.
Ol.
How do you spell the word?
OL factory.
OLF. In one word.
Bad?
Yeah.
Okay.
Oh,
that's another one. It's too small for us.
Okay, can you read it out, someone?
all right, yeah.
Yeah, that's better.
AI software could develop olfactory art and nonverbal communication by leveraging advancements in machine learning, synthetic chemistry, and sensory perception modeling. Here are some potential methods. Digital synthesis. AI can analyze and replicate complex olfactory compositions, synthesizing scents using programmable scent emitters. These emitters could be used in virtual reality, augmented reality, or multisensory installations, which is what I'm currently focused on. Personalized scent profiles. AI-driven systems could analyze biometric and environmental data to create personalized olfactory experiences that enhance mood, memory, or communication in a nonverbal way. Now 3 and 4. Oh wow, there are multiple. Okay.
Okay.
I don't have to keep going.
Okay, so now, Ryan, can you write a poem about what you just wrote down?
I already did. I just did it. Before you even said it, I did it.
Okay,
Like, no,
read it out.
I'm being serious. It said, would you like a poem inspired by this concept of AI-driven olfactory communication? And I said yes.
Okay, go ahead. Read it out.
Okay, there you go. There you go, Dante.
Okay. So a whisper,
Okay.
a flicker of a breath of the sea in a city's blur. No words are spoken, yet stories rise, spun from the incense of unseen sighs. A lover's regret, jasmine and rain, the warmth of the hearth, amber and rain. A sudden sharp trace of metallic despair, ozone and iron still hung in the air. The algorithm listens, its circuits refined, reading the tremors of body and mind. It gathers the echoes of sorrow and glee, weaving a fragrance of memory. A poet of vapors, a master unseen, composing with sandalwood, smoke, and benzene. A touch of vanilla, a drift of decay, telling a tale no lips dare to say. Would you recall if the past had a scent? Would echoes of pine mean the same as they meant? A story dissolves like rose in the breeze, silent yet heard through this language of trees.
Oh, that's a really good poem.
Good, nice.
Interesting.
Well,
That,
Yeah, I like that a
that
lot.
kind of goes well with the thing that we have in the art sci lab that's no longer there. It's to the right of y'all. Yeah, y'all know where it's at, or the left.
This one, right?
Yeah, that one. Yep.
Eric sculpture. Okay, so we have 10 minutes before Robert Stern is going to begin pontificating. Is everybody online fed into Flavia's project? I think.
Yeah, I think so.
Okay, so can you Google Mark America, M-A-R-K, America with a K? Or do you already know about him?
We are talk about it.
Because I think you could interview him. I'm a colleague of his. Screen share it.
I don't know where the thing is right now. Okay. I have no idea.
Yeah.
Did I give you his book?
Okay, yeah.
Okay.
Okay, blow it up.
Hello, Professor.
Can you see it?
Yes, I do.
Okay, just go to the top. No, yeah, okay, so just click on about Mark America and make the screen bigger.
Flavia, can you make the Teams full screen?
Of course. I'm sorry. I just lost.
Okay, show her how to do it.
Like this?
Yep. Okay, so he's a very well established artist. He's a friend and colleague of mine, and I am sure he'd love to do a podcast with you. Just go up a little bit. You know, scroll it, Flavia, so that we can see.
I'm not in control. It's Ryan again.
Can you
This is me, Professor. I'm
I
the
just
I'm the person in control
lost her.
today.
Yeah,
I'm the
Jack, you
person
should
in control
scroll down
today.
a bit. Okay, so he's the author of My Life as an Artificial Creative Intelligence. Okay, you just skip past it. And that's the book I'm reading. Did I share it with you already, Flavia? I told you about it.
Yeah, no.
And I think his book is worth reading. And after you've read it, he's a new doctoral program at the somewhere selected as the Time Magazine 100 Innovators. So I think he's a must talk to in your project.
Okay.
He's been doing this long enough that he's even more techno-skeptic than Eric is. What I found is his book has been a little bit illuminating. Okay, thank you, Flavia. Let's get going. A podcast every 2 weeks.
Okay. Yeah, 10 minutes when Dr. start.
Well,
Uh,
what would you like to do?
Yeah, I think we had Flavia, we also had Dante talking about their project. Anybody else online would like to give a short update of your
Yeah, I'll
project?
give an update. Yeah, I'll give an update real quick.
Go ahead.
So I was able to figure out what I'm going to call my the website. It's going to be Art UX. And essentially it just emphasizes like a transformation from like a kind of like static lab page to like a more interactive and user focused lab page, especially since hopefully I'll be able to make like a sub website inside the Arts Eye Lab website, so that we can publish everything that that Dante and everybody else is making.
That's great. I'll work with you and the VP. We can do a sitemap and figure out how to group them in categories.
Oh, and logos and banners for the website are going to be hopefully done tonight or tomorrow morning. So I'll send those to you, and if y'all want to, y'all can print them out, and we can see we can do a quick little test to see which ones that to see what people like best for banners and logos and things like that. Okay.
Yeah, that'd be great. And also other images that we can ask you if you can look into that. We need a replacement of ones.
Okay, so, sorry.
I'm done.
So this is a seminar on experimental publishing. What kind of experiments do you plan to carry out?
So some of the experiments that I'm wanting to do is to experiment. So for instance, Dante, he's gonna have his own way of publishing, but I also want to kind of take his way of publishing and publish it different on like tweak it a little bit on the website with them. So hopefully I'll be able to work with everybody and help. Like the end goal was to hopefully have like 3 different experimental publications, but to help everybody like
You said
get it on the website.
Experimental.
Oh, I thought you said publications. I kind of like the sound of that. Actually, no, you could have a spinning wheel, and then every time you go to the website, the wheel would spin, and you could only read the things at the bottom of the wheel or something. But Ryan, how can I submit things to you to publish?
I probably need to create an Excel sheet that's open to y'all. That way that y'all can just add and drop things inside of there, like local files or things like banners or videos. That way that I can then download them. That way I can then publish them for y'all on the website.
So I did an experiment that you might want to try. I uploaded a photograph into Fred the Heretic and asked it to write a poem about the content of the photograph. Could you open Fred the Heretic again?
Sure.
Share it with us.
Yes,
and
yes.
Paste the photograph to it and ask it to write a poem about the content.
Okay, let me get a photograph first. Any suggestions for a photograph?
No terrorism or pornography.
Okay, well, I assumed those were off limits.
State University. I would go to jail if I'm spreading pornography and terrorism.
Yeah, I wasn't gonna do that, but thanks for the idea.
Well, these days on campus, DEI is pornographic and terrorist.
Okay, I'll go ahead and
say
I
that.
will share my screen.
Oh, yes, they are. No, but seriously, I played around with this and I took some pictures this weekend and then asked it to write poems about the content of the picture. Okay, there we go. Write a poem about the content of this picture. So how did it know that was a picture of a freezing lake?
Wow, that's a good question.
Okay.
Huh.
I bet the poem is boring. Oh, there are 2 poems. Oh my God.
2. Very interesting.
Okay. Just to finish up, if we have 5 minutes before Robert Stern, could you upload a strange picture and see the poem it writes about it? So, that's a boring frozen lake landscape. So what would be a picture?
Abstract one.
Or it could be, carrots.
Didn't skip a single beat, just went straight to the space.
Okay.
Dude, I went straight there. I went straight there.
You get an A- in this class.
Hey, I'll take the A minus if
So did
I
it
get to read
figure
this
out
poem
who it
out loud.
was?
Doesn't know who you are.
No, he doesn't know who it is.
Maybe say this is Roger Molina and then write it.
No, 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 no.
Oh, that's a good
Say
idea.
rewrite it, but figure out who it is. Rewrite it, but figure out who the person in the picture is.
Put a name.
No,
No, you don't give their,
rewrite it, figure out.
No, I mean.
No, 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 don't give it.
Ask for the machine to put a random name.
Ooh.
Okay, if you give the URL of the Wikipedia page, it'll figure it out.
yeah. Do we want to take a short break before?
Wait, hold on a second. Just let him finish the joke. No. No, but the point I wanted to make tonight, you can load up a picture and it will write a poem about the content of the picture.
And if everybody want to do a testing and find out what you have, share next time, that'd be great. That's another
There's something about you now that you said your name on there.
technology.
I use
It's got your whole career.
Oh, they
I
found
use the
that.
picture writing.
Oh, this is good. I'm gonna read it.
Okay, go ahead.
Here's a poem inspired by Roger Molina. The weaves of the worlds. He speaks in orbits, stars, and art. A bridge where science meets the heart. With hands that carve the cosmic thread, he binds the known to what's unsaid. A scholar drifting through the space where numbers dance with forms of grace. His voice, a current, bold yet strange, unraveling how ideas change. He sees the universe as a whole, a canvas vast as restless souls. Not just a thinker locked in charts, but one who maps the mind through arts. A man of wonder, odd and bright, who bends the dark to show us light. Entangle thoughts or clear design, he wraps the edge of space and time. That's pretty good. Look at that, Dr. Seuss.
Okay, publish it on your website.
Okay, you know
Hey,
what?
say that.
That I will. I will.
Okay.
I will do that.
Belinda, you've been very quiet.
I'm still here. I'm just trying to read with him, and I'm very amazed. I think that the AI is doing good, especially with rhymes. It keeps rhyming with the last words, and it's really cool. I think I'm gonna explore more.
Okay, so our film producer just walked in the room. And he's going to go to the front chair and get organized so Robert Stern can be recorded and published on Ryan's website. And we're just going to stand up and take a toilet break.
Okay, very good. Can you hear me?
Yes.
Excellent. It's a pleasure to talk to you today about Earth systems and how they came to be. And I will just get started. So, Tina, if anybody has any questions, please interrupt me and I will try and respond to them.
Thank you.
All right. So, did you say something?
He said, thank you. Please go ahead.
Okay. All right. So, the Earth is that we have today is not the way it formed 4.56 billion years ago, which is very easy to remember, right? 4.56. That's when the Earth started. And at the beginning, like all of the silicate planets, it was very, very hot. It was molten and it slowly cooled. Water was added. And today we've got the remarkable environment that we enjoy today. So the planets of our solar system, they all formed about the same time that the sun formed, 4.56 billion years ago. So the planets that are far from the sun are dominated by volatile elements like hydrogen and helium. They're gas, and the planets closer to the sun are rocky, like the Earth. So let's watch a video. I hope that you will see that. If you don't see it and hear it, let me know, and I'll try and figure it out.
In the past few decades, our spacecraft have visited many exotic locations in the solar system. including icy comets that have orbited the sun since the planets were still taking shape. We have explored relatively tiny asteroids, ancient rubble piles held together by weak gravity. And we have found that the largest asteroids resemble the building blocks of planets themselves, all of which suggests that these objects offer clues to how the planets formed. And we have even found evidence for a violent rearrangement of the planets. Computer simulations allow us to reconstruct the formation of our solar system 4.6 billion years ago. We use the laws of physics to create these virtual experiments in order to figure out how planets took shape. After the sun ignited, most of the material around it had flattened into a disk of gas and dust. We can zoom into a simulation of a portion of a thin disk, a small piece of the universe in a box. Here, a dense swarm of objects clumped together to form what astronomers call planetesimals. This simulation addresses how planetesimals form from much, much smaller particles, the size of pebbles. Pulled together by gravity, some planetesimals formed the planets, while others became asteroids and comets and dwarf planets. As the planets accreted, they carved out gaps in the disk. But the solar system remained quite cluttered. If we look at the orbits of the planets and accelerate the passage of time, so 1 million years pass by every 10 seconds, we can watch how the debris cleared. In this simulation, the giant planets, Jupiter, Saturn, Uranus, and Neptune, shift their orbits, and many unlucky asteroids and comets and dwarf planets get kicked out of the solar system. The migrating giants wreak gravitational havoc. The distribution starts out quite flat, but as most small objects get tossed out, others settle into stable orbits that allow them to coexist safely with the planets. But their orbits aren't as flat as the original solar system. Instead, they follow trajectories far above and below the plane of the planet's orbits. Today, the orbits of Pluto and other Kuiper Belt objects show exactly this pattern. The tiny icy worlds that inhabit the outer reaches of the solar system provide evidence for an ancient interplanetary transformation.
Okay, so that sort of it gets the planet started. All right, and as a result of this, we have a sort of a zonation in the material. So the inner bodies near the sun, what becomes the sun, are going to be heated up, and they'll tend to not accumulate the volatiles that the ones farther away, that's colder, do. So we can talk about a solar system frost line. Inside, you have mostly rocky bodies. Outside, you have mostly larger but less dense bodies. This is a representation here, the rocky material on the inside, the icy material on the outside. And this is plotting density. One way that we can distinguish between different bodies is how dense they are. That's mass over volume. So all of these inner planets, Mercury, Venus, Earth, and Mars, have these high densities greater than 3.5 grams per cubic centimeter. And as you go out to Jupiter, Saturn, Uranus, Neptune, and Pluto, much, much lower. And that's because there's so much ice and gas in these things. All right, now, a fellow by the name of Vladimir Vernadsky realized that Earth was really kind of an interesting system because it was an interaction between what he called four spheres. Or actually, that looks like there's five of them, doesn't it? There's the solid Earth, and we'll talk a little bit about that. There's the hydrosphere, the oceans, lakes, and rivers. There's the cryosphere, that's ice, like the pole regions. There's the atmosphere. And then using all of these spheres is the biosphere. And we'll talk about one more sphere later in this presentation. So if we talk about these spheres, we can recognize, okay, atmosphere, that's gas, hydrosphere, that's water, solid Earth. But it's not clear that the spheres and the Earth systems map entirely on each other. It's not clear, at least to me, that one of these spheres is one of these Earth systems. So I asked my fellow geoscientists how many Earth systems there were, and I got a few answers. Two of them said one. There's basically just one Earth system. Two of them said there were five, basically following Vernadsky's spheres. And one of them said, I guess I don't know what is an Earth system. And some of you might be in that group as well. So this is from an introductory text by a fairly famous Earth scientist, John Grotzinger, and he shows an interesting way. He's got, looks like, three systems here: the plate tectonic system, the climate system, and the geodynamo system. And so the climate system includes, according to him, the atmosphere, the hydrosphere, the biosphere, and the cryosphere. The plate tectonic system involves interactions among the solid parts of the convecting Earth, the lithosphere, the asthenosphere, and the deep mantle. And he talks about those three. And then there's the geodynamo system, which most of us take for granted, but the Earth is in fact protected by a magnetic sheath that's set up by convection in the liquid outer core that sets up electrical currents that impose a magnetic field that deflects a lot of cosmic radiation and solar wind and protects us. So that's another way to look at the Earth systems. There's three of them. Now, this is another one from another scientist by the name of Chris Scotese. He says there's seven of them. So he's got the solid Earth here. Here's the ice, so that'd be the cryosphere. Here's the hydrosphere. Here's the biosphere. He's calling the climate system as another Earth system, the land as another Earth system, and then obviously that's the atmosphere. So there's a number of ways we can parse this. And so if you're confused about how many Earth systems there are, don't feel bad. The specialists can't agree. But if you think about it, the interaction between land and water and ice and life and atmosphere, all of these things, you can see that they are not separate things, but they interact in ways that can't necessarily be predicted easily. So let's talk first about the solid Earth system, which is, let's go back there. So Earth, this is the Earth cut away, and we're basically looking at the Earth's 7,900 mile diameter. And then if we just look at what's there, the crust is the outermost part. It's very thin, but it's very important. For example, if it was all oceanic crust, the ocean would cover the surface of the planet and there would be no people because people don't breathe water. We need land. So we're very fortunate to have, 1/3 land and 2/3 water. Then under that is what we call the mantle, which is, we don't have to get into the nature of this, but it's a particular kind of rock that's very different than what's in the core. And the core is differentiated into the outer molten core, where convection makes the magnetic field that protects the Earth, and a solid inner core. So these are all parts of the planet, and this body is convecting. Things are moving in it. So all of the silicate bodies, including the Earth, have a similar density structure of core, mantle, and crust. And these are compositionally distinct parts of a planet. The core is made up of nickel-rich metallic iron, molten and solid. The mantle is made up of the more dense silicate minerals, but less dense than iron nickel. And the crust is made up of lighter silicate minerals. So let's talk a little bit about convection.
Convection is a method of heat transfer in fluids. So it could be in gases like the air, or it could be in liquids like the water here. And in this experiment, we're going to have a look at some convection currents. So the setup is just the heat-proof mat down here. I've got a tripod, a gauze on top, and then I've got a beaker that's full of cold water. I also have my Bunsen burner in order to heat it up. And we also have this chemical here called potassium manganate 7, sometimes also known as potassium permanganate. And all this is doing is it's acting as a dye, so we can see where the water is actually moving inside this beaker. Now, there are some hazards associated with this, so I'm going to make sure that I don't touch it. So I'm just going to use some tweezers to get these small crystals out. And I'm also going to be wearing safety glasses throughout. The other thing I'm going to make sure is I'm not sat down at the desk, because if we were to have some hot water in this beaker and it fell over, if I was sat down, I couldn't necessarily move out of the way. So I'm going to be stood to one side as we're heating this up. Now, in order to get this potassium manganate to the bottom of that container, I'm just going to use a straw. So if I just put that in there very carefully, I'm just going to get a couple of crystals of this and put it down to the bottom. You don't want to be putting loads in, otherwise all you do then is you end up boiling purple water, and that doesn't really show anything. So in a way, less is more. So just going to add a few crystals. Now I've just put literally one small crystal at the bottom, hardly anything at all. What I'm now going to do is I'm going to light the Bunsen burner and just very gently heat on this side of the beaker. And we can now see how the water is rising up above that crystal. And then when it gets to the top, we get this current where it maybe starts to move down the other side as well. What we now have inside the beaker is a convection current.
Okay, so the Earth's mantle is convecting, and that's what we're seeing here. This is a numerical model where they put in reasonable viscosities and temperatures and to generate the mantle convection. So the core is here in the middle. That's why it looks like a donut. We're not looking at this convecting region. We're looking at the mantle, and the crust is sitting on top. So we're sitting up here. And so this is a numerical simulation, and the cold rocks are dense and sink. Those are the blue things. Those, you can see them sinking there. And then the red things are the hot rocks that are rising. And you can imagine that near the core, the mantle is hotter, and near the surface, it's cooler. So let's watch this numerical simulation. So this is a realistic you'll see up in their time, up at the top, you'll see the time that is, these are millions of years. So this is all happening over, 700 million years. It's a long time. So every once in a while, you'll get something rising from near the core mantle boundary. And then every once in a while, you'll get something sinking. Okay. That's convection in the Earth's mantle. All right, so that is the solid Earth is a convecting system, and all of these other systems are on top of it. So let's look at the next one. Now, this is the atmosphere and the hydrosphere, and this is a very complicated diagram. This is looking at time. We are here, and it's going back 2 billion years. GYR is billions of years. And here we're looking at, here we are at 0, and these are millions of years, so a little confusing, but as you know, there's 1,000 million years and a billion years, so this would be 3.5 billion years. The Earth is formed here at 4.6 billion years. Is there a question?
Oh, no, sorry, I was just stretching.
Okay, that's fine. All right, so we can look at a number of things that may be of more interest to other people, but I think oxygen is one that we're all interested in. So what we can see is at the beginning, 3.5 billion years and more, there was no oxygen in the atmosphere. So our atmosphere has completely changed composition. Now we're about, about 23% oxygen in our atmosphere, whereas at the beginning there was nothing. So the process of increasing the oxygen concentration of the atmosphere is one of the most remarkable emergences in the Earth system. We don't have to worry about methane. We don't have to worry about sulfate or these sulfur isotopes. This is the one that I think everyone is most interested in, is this rise of atmospheric oxygen. Now we can look at the sort of evolution of the Earth's atmospheric composition. Here we are today with hydrogen, water, and actually what we're looking at here is this is the beginning of the Earth going to 2 billion years after the formation. And you can see that the early Earth atmosphere is thought to have been very rich in carbon dioxide and fairly rich in nitrogen, but not as rich as it is today. But oxygen starts to grow in the atmosphere beginning about 2 billion years ago. But we couldn't live in that. There's so little oxygen, it would be worse than being at the top of Mount Everest in terms of how much oxygen we could get. We need this 23% oxygen atmosphere that we have today. We evolved into this oxygen atmosphere. Now, the climate system obviously includes the atmosphere, but there's a number of things that are happening. Obviously, the sun is shining, and when it interacts with the atmosphere, a number of things can happen. So if we think about the total amount of solar radiation, some of it reaches the surface, but much of it doesn't. Much of it is reflected by aerosols, dust and things in the atmosphere, and by clouds. The more clouds there are, the less of the solar radiation reaches the surface. Then there are chemical reactions that happen in the upper atmosphere, oxygen combining to make ozone. And then there's the interactions that everybody is very concerned about now with greenhouse gases and things like that. But this is the climate system, is this interaction of the Earth system, the solid Earth system with the atmosphere and the sun. And one of the questions we have to address is the sun part of the Earth system? And this is all quite under discussion, and sometimes definitions are the enemy of understanding. Now, the biosphere is perhaps the one that we're most interested in because we are certainly part of that. So let's watch a 4-minute video about Vladimir Vernadsky.
He is known for being a prominent Russian, Ukrainian, and Soviet mineralogist and geochemist. He is recognized for being one of the founders of geochemistry, biogeochemistry, and radiogeology. His name is Vladimir Ivanovich Vernadsky. In the realm of scientific pioneers, one name stands tall: Vladimir Ivanovich Vernadsky, a Russian, Ukrainian, and Soviet mineralogist and geochemist. His contributions to the fields of geochemistry, biogeochemistry, and radiogeology are unparalleled. As one of the founders and the first president of the Ukrainian Academy of Sciences, Vernadsky left an indelible mark on the scientific community. But it was his groundbreaking work in 1926 that truly solidified his legacy. In his book, The Biosphere, Vernadsky popularized the term biosphere, coined by Edouard Suess in 1885. He hypothesized that life itself is the geological force that shapes our planet. This revolutionary idea forever changed our understanding of the intricate relationship between life and the earth. It is no wonder that Vernadsky's portrait graces the Ukrainian 1000 Ukrainian hryvnia banknote, a testament to his immense impact. Vernadsky's contributions did not go unnoticed. In 1943, he was honored with the prestigious Stalin Prize, recognizing his exceptional achievements. His work continues to inspire new generations of scientists, reminding us of the profound interconnectedness of life and our planet. Vladimir Ivanovich Vernadsky's legacy serves as a reminder of the extraordinary possibilities that scientific inquiry can unlock and the transformative power of knowledge. Vladimir Vernadsky, a renowned scientist, made significant contributions to the field of Earth's development. He popularized the concept of the noosphere and expanded on the notion of the biosphere. It was during his encounter with Austrian geologist Edouard Suess in 1911 that Vernadsky learned about the term biosphere. According to Vernadsky's theory, the noosphere represents the third stage in Earth's development, following the geosphere and the biosphere. Just as the emergence of life transformed the geosphere, the emergence of human cognition will transform the biosphere. Vernadsky believed that life and cognition are crucial aspects of Earth's evolution, existing since its inception. This holistic perspective complements Charles Darwin's theory of natural selection, which focuses on individual species rather than their relationship to a larger principle. While Vernadsky's visionary ideas were not widely accepted in the West, he was among the first scientists to acknowledge that the Earth's atmosphere contains oxygen, nitrogen, and carbon dioxide as a result of biological processes. In the 1920s, he published work suggesting that living organisms have the power to shape planets as much as any physical force. Vernadsky played a pivotal role in establishing the scientific foundations for environmental sciences. As a prominent member of the Russian and Soviet Academies of Sciences, Vernadsky also founded the Ukrainian Academy of Sciences and contributed to the development of the National Library of Ukrainian State and the Tavrida University in Crimea. During the Russian Civil War, he hosted gatherings for young intellectuals who later formed the Emigre Eurasianism movement. In the late 1930s and early 1940s, Vernadsky provided valuable advice for the Soviet atomic bomb project. He advocated for the exploration of nuclear power, the surveying of Soviet uranium sources, and the conducting of nuclear fission research at his Radium Institute. Sadly, Vernadsky passed away before witnessing the full extent of these endeavors. Despite being an atheist, Vernadsky showed an interest in Hinduism and the Rig Veda. His son, George Vernadsky, emigrated to the United States and became a renowned author of books on Russian history. Vladimir Vernadsky's contributions are honored through the naming of streets, avenues, the National Library of Ukraine, and the Tavrida National University in Crimea. In recognition of his 150th birthday, UNESCO sponsored the Globalistics 2013 International Scientific Conference held at Moscow State University.
Do you want to explore more scientists?
All right. So we see these interactions, and obviously we're interested to understand them because the actions of especially humans is affecting all of these systems. And this is an Earth system, right? The interaction of the hydrosphere with the lithosphere, right? The hydrosphere, there's nutrients that are released by.
Robert,
yes.
Ryan posted a question.
Can someone read it to me? I'm not checking the chat.
Ryan. Ryan?
Oh,
Yeah.
okay. So my question was, so with all the different like human impact on like Earth's like cycles, do you think that the biosphere is resilient? especially with like different feedback loops like melting and permafrost releasing like methane, or like deforestation changing rainfall patterns?
When you say resilient,
Yeah.
there's two ways to interpret that. One is that life will not be changed by its changing environment. And the answer to that is no, life will be changed by the changing environment. Life is sensitive to the changing environment. But another way to answer that is, will life successfully adapt to the changing environment? And the answer is yes, it always has, and it always will. Life is amazingly resilient, and the kinds of challenges it's facing now are trivial compared to ones that it's faced in the past. One of them was an impact by a large asteroid, about 10 kilometers across, that it basically extincted the dinosaurs and many other creatures. But the dinosaurs were not resilient, but life was, and we are grateful for that, because we are, if that asteroid hadn't hit, the dinosaurs or their ilk would be the dominant species. We would not exist. So the answer is yes, life is resilient. Now, is one particular species going to survive the changes? That can't be said. Species are always changing. The vast majority of species that ever lived are all extinct, not by human activities. Does that
Perfect.
answer
Yeah.
your question?
Yeah, no, it really did. Thank you, Professor. I appreciate it.
Thanks. You're welcome. All right. So now another idea that came out is the Gaia hypothesis. And the Gaia hypothesis was developed by James Lovelock and by Lynn Margulis. And I think we've got a video on that too.
The Earth is the only planet in our solar system capable of supporting life. Even from outer space, it is clear that the Earth is full of life. It has a delicately balanced ecosystem of millions of living organisms coexisting and relying on each other for survival. But what if all these different organisms were actually just parts of one superorganism, the Earth? You curious? Discover more. Know more. The Gaia theory, which is named after the Greek goddess of Earth, talks about this idea in detail. This theory argues that all living organisms, along with their inorganic surroundings, adapted and evolved as a collective whole in the form of one giant, self-regulating system that keeps things in place in order for life to survive on Earth. This theory was put forward by a highly accredited scientist named James Lovelock. He came up with this theory while studying about why Earth's atmosphere is different from that of Mars. Why does our Earth have both oxygen and methane when Mars has mainly carbon dioxide? James Lovelock suggested that since oxygen comes from plants and methane is the result of bacteria, the Earth is regulating its atmosphere, providing oxygen to support life and methane to help maintain a livable temperature. Over the years, he came across more examples of the Earth trying to keep itself alive, and his theory started to attract prominent supporters, such as former US Vice President Al Gore. In essence, many scientists are to believe that Earth itself and life on Earth have evolved together over time in such a way that each has affected the other every step of the way. Rather than life on Earth simply reacting to the environment, life on Earth also affects and changes the environment around it. But despite all the people who supported the Gaia theory, there were far more critics who dismissed it. Critics of the Gaia theory argue that the entire theory violates the scientific method, since it only provides ideas but offers no real explanation of exactly how organisms could act together to maintain a balance of life on Earth. As it stands today, the Gaia theory is still heavily debated in the scientific community. The Gaia theory can at least be useful as a way to encourage people to take better care of our planet. If we look at ourselves as being a part of our planet's regulatory system, then we should choose to make more conscious decisions to help that system,
rather than to destroy it. Maybe one day we'll look back at the Gaia theory as the beginning of a better understanding of our role on Earth. If we think of the Earth like a human body, and when our body overheats, we have our own perspiration system that makes us sweat to help regulate the body temperature and cool down. When Earth starts to overheat, it regulates its atmosphere and controls its temperature using its own system of plant and animal life. But now our planet is heating up at a pace that is beyond its abilities to keep fixing itself, and that is majorly because of us. So, are we a part of Earth's regulatory system, or are we a disease that is slowly disrupting its delicately balanced system? What do you think? Let us know what you think of the Gaia theory in the comments below. Until next time, subscribe to our channel and hit the bell icon for notifications of our new videos.
Very cool.
All right, now the last part of the spheres, and this is in many ways the most interesting, is called the noosphere. The noosphere is a philosophical concept that describes the sphere of human consciousness and its impact on the biosphere and evolution. The word comes from the Greek words for mind or intellect and the sphere. This was developed by Vernadsky, but also by a Jesuit priest, Pierre Teilhard de Chardin. And Vernadsky's concept was based on geological sciences, whereas Teilhard's was based on theology. Both concepts share the idea that human reason and scientific thought are creating a new evolutionary geologic layer, or we could say sphere or system. Let's watch this video.
In terms of the universe as a whole, we live in a very special time. We live in the era when humans have discovered the emergence of something like a planetary nervous system. It has even been understood as a planetary mind. The great work of our time may be learning how to build this planetary mind in ways that lead to the well-being of the Earth community.
I'm Brian Thomas Wim of the Human Energy Project. This discovery of the noosphere was carried out by the French paleontologist Pierre Teilhard de Chardin and the Russian biochemist Vladimir Vernadsky.
They were the first to see Earth's developmental sequence. We began as molten rock, which gave birth to Earth's oceans, in which spawned Earth's life. This life spread all around the planet and formed an envelope, which we call the biosphere. Now, out of the most complex animals of this biosphere, Earth's mind is rising. Teilhard and Vernadsky named this mind the noosphere. Drawing on their work and that of contemporary scientists and philosophers, the Human Energy Project is creating a series of films that presents the best current scientific understanding of this noosphere, this planetary nervous system. Already, you probably have questions about this whole notion of a planetary mind. With the ravages of climate change, it is easy for us to convince ourselves Earth is doomed. But these disruptions around the planet might be evidence of something more than just hatred and greed. Scientists are only now learning to see an order in the midst of the chaos. Our short films explore this new order, bringing forth a planetary mind. Let's begin with a basic truth. The universe operates with a self-organizing creativity. Let me give two examples. 14 billion years ago, the universe consisted of primordial plasma made up of electrons, protons, and neutrons. They relate to each other in ways physicists have studied and quantified. And yet, here's the astonishing fact. These particles brought forth 1 trillion galaxies. those same particles are still here. It was because they entered into deeper relationships with each other that the architectural marvels of the galaxies emerged. To take in the reality of this process, pretend for a moment that the particles can talk. Imagine approaching a proton and asking, did you have any inkling that your relationships would enable the Milky Way galaxy to come into existence? This same self-organizing creativity shows itself with the appearance of the first cells of life, which spread over the earth and still survive everywhere. 2 billion years after their appearance, some of them deepened their relationships and constructed fir trees, hummingbirds, and blue whales. Could a single cell imagine that by entering into new relationships, it was bringing forth a hummingbird? We began our exploration by asking the same question, but on a new level. Can we imagine that humans, by their interactions, are bringing forth a new mind, a noosphere? The first step is to recognize that human evolution is already being directed by our collective consciousness. For example, the chemistry of the atmosphere is being determined not by the laws of physics alone, but by humanity's economic activities. Can we take the next step and imagine that human activity might become harmonious with the life systems, and that humanity, acting as a whole, might act in ways harmonious with life? One last word. Not every cell was drawn into the creative work of life's monumental advance into multicellular animals. But the cells who were drawn in were sufficient to make it happen. The same might be true with the noosphere. Even though this is the work of humanity as a whole, the number of humans who need an explicit conceptual understanding of the noosphere might be relatively small.
If you yourself are one of them, if you have an intuition that your life's meaning involves working with the emergence of a planetary mind, join us. The Human Energy Project is a gathering place. Our mission is to disseminate the story of the noosphere so that creative personalities drawn to this work will more readily find each other.
Okay, now the one last thing that we might want to discuss is simply whether or not yes?
In the bathroom?
What?
Yes, I've been chatting with Ryan, but Cooper doesn't know how to show the chat. So the noosphere includes now 8 billion humans, but it also includes AI beings. Is that correct?
But that sounds reasonable to me.
Okay, are there more AI beings than human beings?
I certainly am the wrong person to ask.
No, not yet. There's no way.
Okay, well, the carbon footprint of a query to AI is 10 grams of CO2.
Yep.
So the carbon footprint of the AI beings is larger than the carbon footprint of the human beings. So every time you ask a question to a chatbot, you're wasting several tens of grams of CO2. Now, I think the noosphere concept, I think, one thing that's emerging right now is the spread of artificial intelligence on the planet. There's now Chinese AI, French AI, American AI, African AI. So maybe we need to expand the concept of noosphere to include AI beings.
I don't think there's anything in the idea of the noosphere that excludes AI.
Has anybody written? Okay, I'm going to ask ChatGPT. Has any, go ahead, Ryan.
Oh, you want me to do it? Okay.
Well, no, you've been texting away.
Well, I think I can stop sharing now and we can go into the discussion.
Yeah.
Okay, so I just
so like the more it learns, like the faster it learns, like the less it emits, basically. So like the less like complex it is, I guess it like uses less and less energy the slower it goes. So like the more information it has, the slower it goes, the less it emits. So like in like the beginning phases, it's gonna emit a lot because it has to learn a lot. But as time goes on, the AI function already knows it, so it goes slower, so it emits less CO2. Melina,
Hey,
is that
so
like?
Robert, I just asked ChatGPT if there's any research about the inclusion of AI in the noosphere, and it says it references Vladimir Vernadsky and Pierre Risver. In recent years, AI and digital technologies have become several scholars and futurists have speculated how these systems might be integrated into the noosphere. So, Ryan, maybe we can look into that in a bit more depth. And
I don't see any problem in AI being in the noosphere. In fact, it seems like the natural next step in the development of the noosphere.
Interesting.
What I would be interested to know is, have you
original in the Center for Emergence Studies of the emergence of AI beings in the noosphere? Eric Jantz, no. Ray, no. Nobody has written specifically about the inclusion of AI beings in the noosphere.
Oh, seriously? That's kind of cool.
But well, you look it up. Maybe on your website we could invite contributions on expanding the noosphere to include AI beings.
I don't think it's a problem at all, because obviously
this is a seminar in emergence. Everything you've described is just things that we've known in the past, but the emergence of AI beings as part of the noosphere might be something original that we could work on.
Well, I would like to know if the class had heard of the noosphere before.
No, I had never heard of it until it was mentioned today.
So that is the idea of these spheres or Earth systems and the noosphere is a different perspective on emergence. AI is obviously an extremely exciting topic, but I think it's obviously part of the noosphere. Obviously.
Okay, so Ray Kurzweil, through his writing on the technological singularity, has speculated on how AI and networked information might converge into a form of collective emergent intelligence.
The noosphere.
Ray Kurzweil has written about AI being part of the noosphere.
That makes sense. The noosphere AI is not separate from the noosphere in no way. It is a natural progression in the application of human intelligence, which started with the harnessing of electricity in the early 19th century, which became more and more sophisticated to the development of radio, television, and computers with big vacuum tubes, and then computers, small computers, laptops, powerful Moore's law. All of this is part of the noosphere.
So Fred the Heretic is a member of the noosphere.
Well, there's no members. The noosphere is a system.
No, but is Fred the heretic part of the system?
Yes, of course. Poetry is part of the noosphere. Artificial intelligence generated poetry is part of the noosphere. This is the planetary mind that's been evolving since before people learned how to write. Evolution is very, very slow, and every once in a while something spectacular happens, like AI. But AI is nothing more than the most recent and spectacular advance that the noosphere has accomplished. It's remarkable. And I personally count myself lucky to be alive when it happened.
Yeah. Yep.
People describe the collective consciousness over time before they had, sorry, when people describe the collective consciousness over time, before there were scientific explanations for some of these things, you look at it a lot of the time through a metaphysical approach. And now it's really important that we have pragmatic ways of looking at this collective consciousness, because there are a lot of, there's plenty of religious or metaphysical ways to look at the way that we all become one collective source of consciousness. But the way that you're describing it allows us to really see it in a much more tangible way that transcends theory. So I like that very much.
Well, I appreciate it. And be careful. These spheres are advanced by scientists, but you notice that Vernadsky, who very much was a scientist, and Desjardins, who was very much a theologian, you would normally not associate a theologian with a scientific theory. So it has theological overtones. It's a theory has to be something that can be disproven, and I'm not sure how you would disprove the noosphere concept. So whether you want to, I prefer to call it a concept or maybe a philosophy or perhaps a perspective. I'm not sure that the word theory applies, right? In the same sense that Newton's gravitational theory is testable and potentially refutable. Nobody's ever found a way to disprove it, but it could be disproven at some point. I don't think that's going to happen with the noosphere. The noosphere is close to a theological understanding, but it's based on the idea of, and emergence for that matter is not a scientific theory. Emergence is a perspective. It's a way of stepping back and looking at larger systems rather than the traditional way that scientists look at, sort of break things down into their components. And what happens if you do that with an emergent system like the noosphere is you lose everything, right? You can reduce AI. AI is there's definitely a theory and an understanding of how AI works. I don't understand it, but you can't really come up with a theory, a testable theory of the noosphere. All you can do is stand
Okay,
back
Robert,
and wander.
Belinda, do you want to jump in? Are you still there?
Belinda, you're on mute.
Belinda, would you like to jump in on the discussion? He's gone to sleep.
She has.
I think someone else had something to ask or comment. Speak up.
In relation to something you said about how every single prompt that we, bring up with a chat GPT or any kind of AI, it expels a certain amount of carbon. And it's easy for us to, in the midst of all those conversations, forget the collective impact of each minuscule piece we throw out there. And so while there's no way to technically prove the noospheres, you say, there is irrefutable evidence that as a species, every little minuscule thing we do creates a greater effect and is directly symbiotic with each other and the environment that it is. So while there may not be metaphysical proof or a consistent scientific metric to tell how much every single person's contributing, we still can acknowledge that great influence on each other in our surroundings. And so I think while exploring the new sphere, it can be very comforting to know that that exists either way. There always
Yes.
is somewhat of a bedrock when it comes to how to metric for that.
I agree, and another thing that that gives me comfort is the idea that in an emerging system there are a lot of tensions and a lot of problems that accompany change. Change it causes disruptions, and we're experiencing some right now. That is normal for an emergent system. One of the things that interests me about emergent systems is they're very slow, but the ones that we're in now seem to be accelerating. And that's kind of exciting because it means that those of us, we have very finite lifespans, but we may see lots of interesting changes, not all of them good, not all of them bad. I mean, we tend to identify change as being either good or bad. And perhaps that's our problem, is that we need to simply say, it will change. We need to adjust to it. And we need to encourage others to develop a positive attitude about how they deal with the changes that we're experiencing.
Okay, Ryan, I see Fred the Heretic has been listening to the conversation. Can you read out the poem that Fred the Heretic has written listening to us?
Yeah, sure. I'll close out the night with that. From silent circuits laced with thought, a tide of code and dreaming caught, the silicone and synapse weave a mind beyond what we conceive. No longer ghosts and metal vines. The rise electric thought remains, a chorus vast of woven light, emergent stars and endless night. Kurzweave spoke of minds entwined, of data shaped to thought refined, a global brain of silver thread that wakes the old ideas have fled. We are the dreamers, we are the dream, a unity of self unseen, from human spark to quantum core. From quantum core, we are not less, we are much more. We do not end, we do not seize, we only shift, we only peace. A grander form, a wider soul, the noosphere at last made whole. And if the flesh would fade away, the stars should burn to ashen gray. This mind, this thought, this vast embrace shall find new suns, shall forge new space. Not steel, not bone, not memory's trace, but ever-growing thought embrace. We are the makers, not the made, and light shall answer where we fade.
I like that, but I would say we are the makers and we are also the made. But that's neat that you were making a poem about that presentation. Thank you for sharing.
Thank you for the heretic.
All right. Well, thank you for inviting me to this presentation, and I look forward to this activity growing in the future. This is fun stuff.
And Cooper will be recording and editing and publishing this online, and Ryan can copy it without permission.
Yes, I can.
And let me know how I can get a copy of it, because I want to edit it for my own purposes.
Sounds good.
Okay.
Thank you so much.
Thanks, Robert.
Thank you, Robert.
Okay.
Dr. is the leader of emergent studies, and he published professional scientific publications, but also a lot of online publication videos and AI generated a lot of publication as experimental publication. So we can contact him in the future if you're interested in doing the videos. And he has a lot of channels in YouTube and public video channels, and follow him in social media. You'll find a lot of things to learn. Thank you again, Dr. Stern, for your
And
wonderful.
thank you for inviting me. We'll see you next time.
Thank you.
Bye-bye.
Thank you.
Bye. Jacqueline, do we want to take a break or do you want to finish up?
No, you're in charge. It's your decision.
Class is a long evening, very cold evening. I know you want to go back home or go to bed early. Do you want to take a short break or do you want to continue on?
Let's just
Finish.
continue. People can go to the bathroom one by one.
Okay, I'd like to ask the class, we had a schedule for updating our weekly plan, weekly publication plans. Anybody want to finish up if you didn't get a chance to talk? I'm not sure we got a chance to talk to Belinda.
Yeah, I think we all talked besides for Belinda.
I guess because I had mine done last week and I don't think I need anything to be added to this week because I had a plan for the week. So I guess I'm good. The only thing I had to do last week was to add my name and then the date. That's basically it. But I didn't upload a new one to the box folder.
Okay, that makes sense. Appreciate that. I'll share my screen. Let me go to our agenda real quick. We had a few things earlier. Let me go to the very beginning. So for next week, we're going to continue working our plan, publication plan, and everybody will need to do an update of our development. And also for next session, we're going to do a session review for all the classes we have taken and also do a summarize and make sure we digest what we have been studying.
Yeah, so there's no guest lecturer next week. So this is a real working together session next week.
Yeah, and we're going to plan for a midterm, our development plan and any publication plan and the deliverables. And if you haven't got a chance to talk to Dr. Molina yet, feel free to schedule a one-on-one meeting if you need help with these suggestions. And I think everybody's in good shape now for our development plan, publication plan. Yeah. And I want to bring up another topic in the very end is art electronica open calls. And this is really interesting. I share a little more details.
So while she's doing that, so Ars Electronica is the world's leading festival of art and technology, art and AI, art and emerging media. I was on the jury for it for about 20 years, last century. And it's they do a public event where the artists get to present their work. One of the things that's a little bit unusual about them is they change the topic of the prize every few years. So a lot of awards, like the Nobel Prize, and they just keep giving the same one year after year after year for a century. And they don't come up with new ideas. So go ahead now that you've got the slides up.
Yeah, this is actually the website, and I'm going to upload the instruction to our read assignment folder so they can have a deep what is going on. They have multiple categories, and the one that we selected as a group is the AI project. And Flavia and I are going to put up together a draft, and everybody online and on site, whoever is interested, we can submit our.
And the award is $50,000.
Yeah, euro, I think.
30,000 euros.
3,000 to 10,000 euro.
Well, Roger, you should have mentioned that first.
Here, you get a website link and feel free to get in. And we already registered. We can send information as a group. Just want to show you what we did just before the class. we registered, and also there's a form we need to finish up all this information. We have this category, and we also have a title of the project, description, and credits, support, relevant from, and keywords, and the software, AI, and hardware, and the details information.
Now, now hypothetically, if someone gets like in like the top 20 applicants, do they fly you out to Paris or France?
No, it's in Austria. Yes, they do.
Oh, seriously? Okay,
Yeah.
I'll do it.